champ. I did it. Now what? What I would do is slap a little ruler right on that bad boy. Not a ruler, but any kind of straight edge. If that pattern that's created looks linear, then the original data set couldn't be considered normally distributed. This does not look like it's a linear relationship. I mean, you can go, look at that. Not linearly organized. Therefore, original data set is not a normal distribution. And we could have done this to check the empirical rule question earlier. Just I didn't want to hit you with 3 different ways of doing the question on the same. I saved this for this. But you look at this, you say, all right, let me try it with a box plot. It looks like it might be symmetrical, maybe not, I'm not really sure. Then you go to this and say, well, that's not a line. The more linear it is, the more normal the original data set is. All right? So the less, the reverse is true. The less linear, the less normal. This doesn't look linear at all. I put a ruler on it, and it doesn't look anywhere near like a line. So we can safely assume that we're not looking at a normal distribution. Now, you can look at something that's pretty much a line, kind of, sort of, missing a couple points here and there. So then we would say it's kind of, sort of a normal distribution. Kind of, sort of is approximate. All right? So it's approximately linear, therefore I have an approximate normal distribution. Okay? So that's really all you need for that. This is supposed to be a gimme, a freebie question. Very quick and easy. Some of us will make it harder than it needs to be because you'll forget that you can do this and you'll go through the empirical rule and it'll take longer than you need it to.
So we definitely don't have to go this out in the test.
You don't have to, you have to justify your answer. So the justification would be to say that the normal probability plot is not linearly organized. Therefore, original data set is not a normal distribution. But what most people are comfortable doing, because obviously I would never expect you to plot this point by point in terms of the scaled graph, but what a lot of people do is they'll just do something like this. And then write this. Got that from my calculator. And that's good enough for me. I just need some way for you to demonstrate that you justified your work. All right, fresh data for a change. Let me just double check one thing real quick. Because that's happened before, where I wipe out the data and then find out I need it for a question down the line. That would just be the worst. All right, so I got an L1 list and an L2 list. Much shorter set of data. Stat, edit, you need to clear out information in L1. Go up to L1, do not hit delete, hit clear. And then just take a moment, take a breath, make sure you absolutely don't need these 31 data points for anything else. And then hit enter. And do the same thing with L2. That's what I was talking about before. Scan through the entire test. See what, when you're about to type that data set in, see what questions that data set applies to. Because you don't want to clear it out before you're ready or before you need to. So 1, couple of 3s, couple of 4s, couple of 7s, and 8 and 10. Couple of 3s, couple of 4s, couple of 7s, and 8 and a 10. Treatment 4. Three 3.383 double check the data. Always double check the data. All right. Determine the line of best fit for the data set. Justify using the coefficient of determination. I don't know what the hell that means. Oh, wait, R squared. Okay, now I know what it means. Between year and duration. All right, so let me get my key press history back on, clear out all this fluff. Have my data in, stat, over to calc. LinReg, linear regression, other name for line of best fit. The default settings are L1 and L2. If they're not listed as L1 and L2, make them L1 and L2. Frequency list, you leave blank. Store regression equation we usually put in, even if we don't need it. All right. In this case, we're going to need it because it says estimate the duration of a total eclipse in the year 2017. So I want to have my store reg EQ in there. So right on down to that. Alpha trace option 1. And let me snip this in. So again, TI-83s do most of the same stuff, but it's a little different when it comes to stuff like this. All right. So again, this is stat, calc, 4. And again, on the TI-84, it's alpha, trace, select Y1. On the TI-83, bars, Y bars, function, Y1. All right, so once you do all that, you hit enter on calculate. And, okay, so my calculator got reset apparently between last class and this one, so something got changed on mine. If yours has the R squared and the R, then you're good to go. You have it the way it ought to be. If yours looks like mine, then you want to do what I'm about to do. All right. If it's a TI-84, then you just go to mode, hit the up arrow. You'll see an option that says stat diagnostics. It should say on. If you have a TI-83, there's no, your mode menu looks different. You have to do it a different way. Say it again. You have to hit the up arrow. You don't have this like with math print and stuff. All right, so I'll run my calculation again, and now everything I need shows up. Although I don't think my calculator got reset, which I think means that some teacher turned off the stat diagnostic between last week and this week, which means that somebody is a fool. It's like the most important part of this. Because it's all well and good to know that you have an equation that fits the data, but what if it's not a good equation? What if it's not a good fit? Jeez Louise. So we'd say, we have our model here, y equals ax plus b, and here's the a, here's the b.
So y equals 0.008x plus 3.417. And I'm justifying it using the r squared. R squared is approximately 0.0217. All right, so it's kind of a weirdly phrased thing, but the justification part is really just telling us to talk about that line of best fit within the context of that r squared value. So we know that if r squared is close to 1, it's a very strong positive correlation. All right, if it's equal to 1, which is rare, I mean, it's ideal, but it's very rare, then it's perfection. Right? It means you have the perfect fit. If you have something that's nowhere near 1, then it's not a good fit for the data set. So not a good fit for data. All right? So the justification part comes into play where it's like, when you take a look at the picture, when you take a look at the scatter plot, you look at the line and notice that it doesn't go anywhere near passing through all these points. And then you say to yourself, well, okay, did I either screw this up, or is it just not a good fit? The r squared is going to tell you whether you screwed it up or if it's not a good fit. Right? If r squared is close to 0, it's just not a good fit. If r squared is close to 1, it's a really good fit. And if your line doesn't look like it's going through all those data points, then you done did something wrong. All right. Now, also, the r squared is telling us to take everything with a grain of salt, because if you're looking at the estimation in part B, I'm about to plug in a number to my equation and get an answer. That r squared is going to tell us how reliable that answer is. If you're talking about an r squared equal to 1, you're talking about an equation that's reliable all the time. Right? It's reliable 100% of the time. That's what that percent of variation is telling us, the coefficient of determination. If you got an r squared equal to 0, it's telling us that it's never reliable. And then anything in between has got some varying degree of reliability. Right? So this is saying it's not going to be very reliable at all, but since we have nothing else, we might as well. All right? Now, these are years since 2000, so when I want the year 2017, I'm looking for the y value. So find y when x is equal to 17. Now that I have an equation stored into y1 in my calculator, so I can hit y1, there's that lovely equation. But in my home screen, all I have to do is type in alpha, trace, select y1, pop in the 17, and hit enter. So not asking you to do algebra. I think ever. I'm trying to, just like kind of flashing through the course. I don't think I'm asking you to do algebra ever. Year since in this course. 2000, we did, this is the same y1 as before. I'll write it again, alpha, trace, y1. And then this is giving us the result, which in context, it's talking duration in, didn't give units, but I would imagine it's minutes. But it doesn't matter because it didn't give units, so we're not on the hook for the units. All right, so this would be just duration. But seconds and hours don't seem to make sense in this context. Page 3? I don't know. What page was this? I lost track.